Assalamualaikum and a very good day to everyone. My name is Fatin Asma binti Rozali and my metric number is E23A2897. I'm currently pursuing a Bachelor of Applied Science Environmental Sustainability Science with honor. My field of interest is water quality, especially in relation to the impact of human activity on river ecosystem. This presentation is part of my mini project entitled Quantification of Iron Concentration in Sungai Kelait, Gua Musang. Sungai Kelait, located in Gua Musang, Kelantan, is a vital water source and habitat for aquatic life. Recently, this area has experienced an increase in iron ore mining activities. Such activities may lead to pollution, which can impact the health of nearby community, especially the orang asli who depends heavily on the river. The growing number of mining activities may result in heavy metal contamination, particularly iron, in the river water. High iron level can harm water quality, threaten aquatic life and affect human health. However, scientific data on iron level in Sungai Kelait is still limited. This study has two main objectives. First, to determine the concentration of iron in Sungai Kelait. Second, to provide scientific data for future monitoring and pollution management strategies. This study focuses on measuring iron concentration in river water, evaluating potential health risks for communities using the river, and assessing the impact on water quality and aquatic ecosystem. This research is significant because it provides essential data on iron levels in the river, support environmental monitoring and pollution control, and raise public awareness about the impact of mining on nature and human health. The study area is Sungai Kelait, located in Gua Musang, Kelantan. This area is close to active iron ore mining site. 5 sampling points were selected along the river, covering upstream, midstream and downstream to detect iron levels in different locations. In recent years, studies have shown an increase in iron pollution in river, mainly due to mining activities in rural area of Malaysia. A study by Ismail et al. 2024 highlight the urgent need for continuous monitoring of heavy metal in river, especially in high-risk area like Gua Musang. Norden et al. 2021 found that river near mining site record iron levels exceeding the NWQS limit of 1.0 mg per liter, making the water unsafe for daily use. Jali et al. 2022 report that orang asli communities are the most affected, experiencing skin and digestive issue linked to high iron level. Lee et al. 2023 proved through GIS mapping that area closer to mines have higher iron content. Tan et al. 2023 also found that iron levels increase during the rainy season, sometimes reaching over 5.0 mg per liter due to runoff from mining area. Lastly, Hassan et al. 2024 stressed that need to stricter enforcement of environmental law as current post-mining monitoring is still weak. This study showed that iron pollution is a serious issue, especially for vulnerable communities. My study will contribute update data for Sungai Kelait, supporting effort in sustainable water management. The steps involved in this study are: water sample were collected from 5 locations along the river. Sample was stored in sterilized polyethylene bottles and preserved with nitric acid to stabilize iron. The sample were filtered to remove suspended particles. Atomic absorption spectrophotometry (AAS) was used to measure the concentration of iron accurately. Now I will explain the overall flow of my research process as shown in this flowchart. The first step is identifying the main issue, which the potential iron contamination in Sungai Kelait due to nearby mining activities. Next, I review previous research from the year 2020 to 2025. This helped me understand how iron affect river system and human health, especially in rural and orang asli communities. I then designed the sampling plan, including selecting 5 strategic points along the river, covering upstream, midstream, and downstream area. Water samples were collected from this selected location using sterilized bottle and preserved using nitric acid to maintain sample stability. Samples were tested in the lab using the atomic absorption spectrophotometry method to determine the exact concentration of iron. The results were then compared with the national water quality standard to see if the iron level exceeds safe limits. Finally, I interpreted the finding and made the conclusion based on the data, highlighting the impact on water quality and recommendation for future monitoring and action. This flowchart summarizes the key steps taken throughout the research process, from problem identification to the data analysis and final reporting. Gantt chart and milestone. This Gantt chart and milestone show the timeline helped me to organize the study efficiently from topic selection until the final submission. Research budget. This budget covers all essential expenses from fieldwork to final report submission. That's all. Thank you.